So thank you very much, Ben, and it's a pleasure to speak to you this morning. As Ben said, I'm the director of a new and ambitious climate change initiative at the University of Cambridge, which is being called Cambridge Zero and will be launched later next month. So if anybody wants to ask me about that during the course of today, then I'm very happy to answer any questions. But what I'm going to talk to you now about is our scientific understanding of our changing climate. And I thought I'd start off, first of all, just with a dashboard of some of the key data sets that show how our world has been changing over the last 150 years. And in the top in blue, I've got a couple of, just two measures of how our society has been changing over that time period. And there's been about a 100-fold increase in global GDP as society in many countries of the world has been completely transformed over that period. But of course, much of that transformation has come about as a consequence of industrialization, and that industrialization powered by the use of fossil fuels. So we've seen a 20-fold increase in energy use over that time period. Fossil fuel use drives carbon dioxide emissions, and alongside changes in land use, there's also associated with that development, we've seen a dramatic increase in carbon dioxide in the atmosphere. Carbon dioxide is a greenhouse gas, so you would expect a warming of the atmosphere as a consequence of that. And indeed, at the bottom you see measures of how our climate has been changing over this time period. More than 1 degree increase in temperature over the last 150 years. And there's just one other measure of our changing climate, 25 centimetres increase in sea level rise over that period. And I'll speak more about sea level rise in particular over the course of the rest of this talk. So let's just pick out of that data just two key numbers, which I want to provide a little bit more context to. So the first number is around the increase in carbon dioxide. So if we go back just a few decades, back to 1960, carbon dioxide levels in the atmosphere in 1960 were 315 parts per million. Today, some days of the year, this year, they've topped 415 parts per million. And that difference of 100 parts per million is really significant. I want you to remember that number because I'm going to show you how significant that is in a long-term geological context. And the other number I want to just highlight is the really rapid warming we've seen just in the last couple of decades. So if you go back to the 1980s and look at the temperature difference between the 1980s and where we've been over the last decade, there's been 0.5 degree Celsius increase in temperature just over that short time period. Another 0.5 degree increase from where we are today would take us beyond 1.5 degrees of warming. And many of you may be aware that the Paris Agreement of 2015 stated that we wanted to keep temperatures well below 2 degrees of warming with an ambition to keep them below that 1.5 degrees threshold. So that 100 parts per million increase in carbon dioxide since 1960, why do I say that that's important? Well, from Antarctica, we can get a record of climatic changes going back hundreds of thousands of years. And we obtain that from ice cores drilled into the Antarctic ice sheet. And you can see a photograph of a slice through one of those ice cores. We're able to actually obtain the air, which you can see in bubbles in that ice core, that was in the atmosphere hundreds of thousands of years ago from the ice in Antarctica, and measure what the actual carbon dioxide has been in the past. And the record, the graph that you see here, is the record of the ice, of the carbon dioxide in the atmosphere over almost the last 1 million years. And what you can see is that it varies for most of that time period up and down between about 180 and 280 parts per million, varying up and down by that magic 100 parts per million. The world has been in very, very different climatic states over that period, where there are low carbon dioxide levels. That was during ice age periods, higher carbon dioxide levels in the warmer periods in between. That natural cycle of change is driven by changes over very long time periods in the orbit of the Earth about the Sun. So sometimes the Earth is a bit closer to the sun and we're in a warmer period, sometimes a bit further away from the sun. What you can see is where today's carbon dioxide levels are in comparison to that, vastly outside the natural cycle. The amount of change that we made in the last couple of decades, or last few decades since 1960, is equivalent to the same level that was driven by orbital changes of the Earth about the sun. So I think that really puts into perspective quite what a radical change we've been making to our atmosphere. Some of you might have visited this glacier in the Alps if you want a slightly different perspective on our changing climate. This is a very famous glacier in the Mont Blanc region. The top picture here, you see a postcard that was produced in around about 1900. This glacier is called the Mer de Glace glacier because it literally, as you can see in that postcard, used to look like a sea of ice. Today, the bottom picture doesn't look quite so much like a sea of ice. Back in 1988, a cable car was put in place so that you could go and tourists could go and visit an ice cave that was carved into the glacier each year. In 1988, you came 3 steps off the cable car into the ice cave. Today, the glacier has melted down so much you have to go down nearly 500 steps. Again, that's just since 1988 to today. Very visible indication of the rapid scale of change. And we're starting to see the effects of that changing climate in terms of the risks of extreme weather events occurring around the world. This is a map that's been put together by an organisation called Carbon Brief, which has collated the studies that have been conducted over the last couple of years that have looked at actual extreme weather events that have occurred around the world and asked the question, has the risk of those extreme weather events increased as a consequence of the climate change we've seen to date? And in many, many instances, we've been able to demonstrate that indeed that risk has increased and in some cases increased very, very substantially. So all the dots that you see coloured red are examples where we've shown that increased in risk. There are some cases shown in blue or in grey where we've not been able to demonstrate a connection. But there are more than 200 studies now that show a strong connection between increased risk of extreme weather occurring here and now today, affecting lives and livelihoods around the world. I won't go into any of the particular examples. You can look online if you're interested. But they represent flooding events that we've seen in the UK, resulting in billions of pounds worth of damage in recent years. Extreme heat waves, for example, in China, or other extreme weather events in other parts of the world. And of course, extreme weather can have both a direct impact on assets and resources, but also an indirect impact either through supply chains or indeed through financial systems. And to fully understand and quantify the risks associated with climate change arising through this, not only do you need to quantify both the direct and the indirect effects, but you also need to understand all the correlations. These extreme weather events are happening around the world. In some instances, we're seeing sustained damage that sometimes is correlated in time. We're seeing correlations across geographies. We're seeing interconnections between different systems. And understanding all those interconnections is essential if you're to properly quantify the real risk, whether it's to some aspect of society or to global financial systems. Just in the last couple of weeks, a new report, a special report from the IPCC, the Intergovernmental Panel on Climate Change, came out specifically looking at the oceans and the frozen parts of the world. And so I wanted to just highlight a few of the key aspects that were highlighted in that report. The first is that Greenland and Antarctica are both losing ice at an accelerating rate. And together with warming of the global oceans, that is contributing to sea level rise, which is also accelerating. There are other impacts on the ocean, not just the warming, but we're also seeing, as a consequence of the warming, oxygen levels in much of the world's ocean dropping, particularly in some of the rich upwelling regions, which have a lot of marine diversity in them. And another key concern is the levels of acidification in the ocean. At the moment, our carbon dioxide emissions, only about half of them stay in the atmosphere. The other half is either taken up by the land or the oceans. But when it's taken up by the oceans, it makes the oceans more acidic. And that is causing particular damage to coral reefs, but also having impact across marine ecosystems. Our oceans are acidifying at a faster rate than we've seen in hundreds of millions of years. Now, of course, we've known about climate change for many decades now. I put this up here. This was the very first IPCC report back in 1990. I won't read out what it said, but it was very clear back in 1990 that climate change was, as it said, a cause of potentially significant impacts on society. So we've known about the problem for many decades now, but done very little as a global society. On the right-hand side there, you see the warming over recent decades. You can run complex computer models to see where that warming is going to take us if we continue on our current trend, or you can just literally draw a straight line through our current rate of warming, which is what I've done for this slide. Either way around, you find that we're on course at our current rate of warming to exceed 1.5 degrees of warming sometime between about 2030 and 2050. And what does that mean? What's the risk of exceeding 1.5 degrees? Well, it's estimated that if we move between 1.5 and towards 2 degrees of warming, some 100 million additional people will be exposed to the effects of both poverty and climate change. And it's many of the communities that are already most vulnerable and indeed least responsible for the climate change that we've seen to date who are likely to be most impacted. These photographs come from an island off the coast of Mozambique, Ibo, which was absolutely decimated by a cyclone earlier this year. I've already mentioned the impact of ocean acidification on our coral reefs, but ecosystems throughout the world are already showing signs of impacts of climate change. On the left here, I just showed 2 UK bird species which are potentially at risk from climate change. The top is a mountain blackbird. For any of you bird enthusiasts, it's a ring ousel. It lives up mountains, and so consequently, as the world warms up, its habitat is shrinking, and indeed, as we increase in warming, we're in danger of this bird becoming disappearing from the British Isles altogether. Blue tits are an example of a species that's very exposed to changes in seasonal timings. So they were reliant on caterpillars to feed their chicks. If you get a shift in the seasonal timings, as we're seeing, then that can cause significant impacts for them. The next example comes from the marine area. This is kelp forests in the ocean, which are a very rich ecosystem susceptible to increases in warming. And other iconic species such as the emperor penguins, very reliant on sea ice as part of their habitat, and consequently, again, susceptible to even relatively small increases in temperature. And the other great concern is the risk of a really catastrophic shock to the climate system, abrupt or irreversible changes. We know that these have happened in the geologic past. Indeed, just in the North Atlantic region, there are dozens of examples of rapid climate change over the last 100,000 years. Here are just a few of the examples that we're concerned about. The first, on the top left, is a lake in the Arctic. The circle that you can see is a bubble of methane coming out of that lake. There are large amounts of methane in the frozen lands and oceans and lakes of the Arctic. And the concern is that as the world warms up, this might be released into the atmosphere. Methane is a much more powerful greenhouse gas than carbon dioxide. We're concerned about the potential for the rapid dieback of the Amazon rainforest, turning from a rainforest that soaks up large amounts of carbon dioxide into a savanna. And we're particularly concerned about the vast ice sheets covering Greenland and West Antarctica. This is a photograph from the Greenland ice sheet, which has shown significant melting over recent years. Greenland ice sheet has the equivalent of 7 metres of sea level rise in it. West Antarctica, probably around about 3 metres of sea level rise in it. Some of the key glaciers that are critical to the stability of the West Antarctic ice sheet are thought to potentially already be in irreversible retreat. The map that I show here just gives an indication just in the Asian region of where the large growing megacities of the world are. They would be exposed to much less than multi-metres of sea level rise. And so the potential for increased ice loss from Greenland and Antarctica is a cause of very great concern. Indeed, 10% of the global population currently lives in low-lying coastal regions, and that's only anticipated to increase over time. So the last thing, and perhaps the most important slide, if you remember one thing from this talk, it's to remember this slide, is looking at our current trajectory of carbon dioxide emissions and the future trajectory that we would need to be on if we were to have a good chance of keeping temperatures below 1.5 degrees Celsius. This comes from the IPCC report of last year. And what you can see essentially is that over the next decade, by 2030 or so, we need to halve emissions compared to today, completely reversing the trajectory that we're currently on, taking our emissions levels back to the levels that they were in 1980, globally reaching net zero emissions by around about the middle of this century, and then actively taking carbon dioxide out of the atmosphere for the rest of the century and beyond. So it's quite a monumental challenge, and we are absolutely not on this trajectory at the moment, despite all international agreements. Very last thing that I want to say is you know, I've been explaining the climate science for several decades now, and I feel like I've been doing an awful lot of the doom and gloom side of the story. My new role in Cambridge, with the new broad climate change initiative that we're running in the university, finally I get to give the optimism, hope side of the story, which is how we can really try to mobilise across all of our expertise, from the engineering side through the AI, through the work that we might be doing on new modes of transport or new ways of taking greenhouse gases out of the atmosphere, new ways of looking at how we measure prosperity. If we can really bring all these things together, and especially with how we look at the finance community, then maybe we have a hope of actually solving this climate challenge. And I'll leave you just with this one image. This is the image of the Earth that was taken in the Apollo mission, known as the blue marble. It was the first photograph of the Earth from space. It's supposed to be the most reproduced image in the world, and it's almost coming up for its 50th anniversary. And I always feel that, if anything demonstrates both human ingenuity in getting us into space to take that image in the first place, but also the very critical beauty and fragility of our Earth, it really is decisions that we make today and over, frankly, the next couple of years that will determine the legacy that we leave to future generations who are going to be living on this planet. So, thank you.
Hello, I'm Katia, and I work for the UK Embassy in Brazil, managing the Green Finance Prosperity Fund program. I was wondering, how do you see the proximity between the nature agenda and the climate agenda in the next years? Do you think there is possibility to start engaging these conversations together instead of separating the two topics as they were completely different issues, instead of looking at the opportunities that there are when we bring them together? Thank you.
I mean, absolutely. So clearly it's important to understand both the impacts of climate change on the natural world, but more importantly, or as importantly, how the natural world can be used to help drive some of the solutions to climate change itself. So absolutely. And then follows on how, you know, aspects that are more relevant to this community, but how do you help to finance that?
Hi, I'm Jo Paisley from the Global Association of Risk Professionals, and we major in risk education. And we've been working a lot on climate change over the last year, trying to mainstream it within risk management, but I find that there's a kind of disconnect. People can see a presentation like yours and they get it, and then they kind of go back to their day job and they forget, and they don't know what they need to do, and that's even well-meaning people. What do you think we can do to bridge that gap, or is it a matter that policy basically is what's needed? You know, we need a carbon tax, we need to give the right financial incentives to get the right outcome, because I don't know how we build capability and awareness of what people actually need to do.
I think it's both. So I think you need to have the right policies and regulations in place. But what I find a lot, I mean, even within Cambridge University, we're trying to undergo a pretty ambitious program of decarbonisation of the university itself. And when it comes down to day-to-day decisions, you need the evidence base to understand what you should be doing to be most effective. And so I think there's an awful lot of developing that evidence base and sharing it, because the scale of the transition that's required is extremely rapid, and we are really only going to be able to do it at that speed if we are very, very collaborative in how we do it. So I think it's a big challenge.